The first thing I'm going to do is go over your warm-up, which you should have already turned in. So number 1 said solve for x. So you want to draw your line and circle x. What letter needs to move away from x? Well, k is beside it, so k needs to move. And remember that these are being multiplied. So the opposite of multiplying is to divide. So you want to divide by k. You want to move k away and you want to divide it. So that moves k. So you can write your answer, x equals y over k. If you left your answer like this, that is okay too. Just make sure you have divide by k. Number 2 says, note the following regarding a vacation and a car rental company. A car costs $45 per day. A car costs 11 cents per mile, and you drive 100 miles on the vacation. Which function rule represents the cost of car rental for X number of days? You should have circled X as the number of days. Well, what do they tell you about days? It's $45 per day. So that has to be 45x. So which answers don't have 45x in them? Well, B is the only one, but we can at least get rid of that one. They also tell you that it's 11 cents per mile, but you know how many miles you're driving. You're driving 800 miles. So you need to multiply those. 0.11 times 800. You may use your calculator on that, and it gives you, pull up the calculator, 0.11 times 800 gives you 88. So the answer is A, 45x plus 88. Okay, today's lesson is on predictions. So using stat edit and making predictions. All right, so you should have a handout on which to take notes. The first problem says, a set of data is shown in the table below. Assuming a linear relationship, what is the predicted value of y when x equals 4? So when you see a table like this, you want to put it into stat, which we learned how to do on Monday. So I am going to go to my calculator and hit stat, edit, and I'm going to put in 1, 2, 3, 5, and 6. And on L2, I'm going to put in 12.6, 15.4, 18.5, and 24.2, and 27.4. You need to be doing this as well. You should have put this in your calculator. If you need to, pause the video and put these numbers in your calculator. Then we'll hit stat again, go over to calc, down to number 4. Enter, enter, enter. Today I want you to go 3 decimal places. 3 decimal places. So I'm going to write y equals, and the calculator says A is 2.951. The 1 doesn't round because there's a 1 next to it. So 2.951. 2.591. And you put an X beside of that. Then the calculator says B is 9.586. 9.586. So plus 9.586. Okay, so you need to write this on your paper. You feel free to pause the video at any time to catch up. All right, the next thing you're going to do, this is what's new today. So look on your computer screen. You are going to hit the Y equals button on your calculator. It's in the top left. If you look on the screen right now, I'm circling it with my mouse. So you're going to hit the Y equals button, and you're going to type this in. So you're going to type in 2.591. You need to do this on your own calculator. The X button is underneath the mode button. So you can see again, I'm circling it with my mouse. I'm going to hit the X button, plus 9.586. Pause the video if you need to catch up. The next thing that we are going to do is we're going to read the question. So the question says, what is the predicted value of y when x equals 4? When x equals 4. Okay, so in our calculator, you have it in the y equals. The next thing you're going to do is you're going to hit second graph. And the calculator does a table for you. So it wanted to know when x equals 4 what the answer would be. Well, here's x, so we'll go down to 4. And if you look, it's 19.95. So the closest answer to that would be 20.4. That would be the closest answer. I'm going to double check what I have in my y equals. 2.591x plus 9.586. All right, I'm also double checking what's in stat real quick just to make sure I did everything right. 1, 2, 3, 5, 6, 12.6, 15.4, 18.5, 24.2, 20. Yeah, good. Okay, if your calculator did not have 0, 1, 2, 3, 4, then you're going to need to tell the calculator to start at 0. So you would hit second window, and you would make sure that there was a 0 in that top thing, and then you would hit second graph again if yours didn't have the right numbers. Okay, so that is number 1. Number 2, what is the value of y when x equals 18? Okay, the first thing you need to do is put things in stat. L1 and L2. Okay, type the numbers in your calculator. So we'll clear these out. 5, 7, 9, and 11. Please do this with me. 7, 11, 15, and 19. All right, press stat again. Go over to count down to number 4. Pause the video if you need to. All right, so this one there's no decimals, so it's going to be y equals, the a value is 2. I put x next to that, minus 3. The next thing I'm going to do, so please write this down on your paper. The next thing I'm going to do is go to the y equals button. So I'm going to put the y equals in the y equals button. So the y equals button is the one up here. It's gray on the top. So I'll clear that out. Press the clear button. So I'm going to put in 2x minus 3. And you're going to go to second graph. All right, so let's see what it says now. The question says, what is the value of y when x is 18? So I'll scroll down to 18. So use your arrow keys, and the answer is 33. Okay, so I'll show you on the calculator again. Scroll down to 18, and you get 33 as the y value. All right, number 2. The Smiths' average monthly electric bills in the years 1998 to 2005 are displayed in the table below. According to the line of best fit for the data, approximately how much would the Smith's pay per month in 2007. Okay, so we're going to put them in stat. Go to stat, edit, clear out this. All right, so you're going to type in 1998. $19.99, 2000, 2001, 2002, 2003, 4, and 2005. All right, 102, 104, 108, 16. Okay, so I put these in L1 and these in L2. Okay, so just like always, I hit stat, go over to calc, down to number 4, enter, enter, enter. All right, we're going to go 3 decimal places. So if you look, it's 3.904. But the 4 rounds up because the 7 is bigger than 5. All right, so if it's more than 5, you got to round up. So 3.905 is what I'm going to write. Y equals 3.905. And you always put an X beside that. That's your slope. All right, the B value, negative 7703.131. So you would write minus 77, let's see, 03. Okay, so we have 7703. We want to go 3 decimal places. So 0.131, because the 0 will round up. So 0.131. Okay, now we're going to type that in our y equals. So you go to your y equals, and you are going to type in 3.905x minus 7703.131, and go to second table. Okay, now if you look, the question says, how much would you pay in 2007? Okay, so everybody look at the screen right now, please. You have to tell the calculator to go to 2007. You don't want to have to scroll all the way down to 2007. That'll take forever. So you want to hit second window, and you want to type in 2007. So I hit second window is what I did. Now we're going to hit second graph again. So you go back to your table. And in 2007, they're going to pay 134.2. So that is answer choice A. All right, number 4. The table shows the height and number of floors in 13 buildings in Cleveland, Ohio. What is the reasonable prediction of a number of floors of a 1,000-foot tall building? Okay, so we got to put all these numbers in stat. Just think about it like you're texting. So I'm going to hit stat, edit, and clear out all this. All right, so you're going to put in 888, 708, 658. So you need to be putting this in your own calculator. So pause the video if you want. While we're doing this, please put them in your own calculator. It doesn't help to just watch. You have to do it. Okay, and then you're going to go over to L2 and put in the ones that go with it. All right, and you press Stat, over to Calc, down to number 4. If you need more time, pause the video. All right, we're going to go 3 decimal places, so it's 0.065, and it doesn't round up. So y equals 0.065, and I put an X beside of it. And then the B value is 2.516, but that 6 rounds up because there's a 7 after it. So 2.517 plus 2.517. So write this on your paper. All right, where are we going to go next? Good, we're going to hit the Y equals button, clear it out. 0.065x plus 2.517. All right, now we need to see what the question's asking. What would be a reasonable prediction of the number of floors of a 1,000-foot tall building? 1,000-foot tall is a height, so that's an X. So we need to go to 1,000 in our X column. So we're going to go second table, and we are looking for 1,000 in the X. So we're going to go to second window and type in 1,000. And go to second graph. And for 1,000, 67.5. So the best answer choice is A. That's the closest one. All right, number 5. For what value of x does y equal 13? So make sure you're paying attention. That's y equals 13. So we're going to do what we always do. Put it in stat. All right, so -2, -1, 0, 1, 2, 3. -3, -1, 1, 3. Oops, sorry guys. My fault. All right, -3, -1, 1, 3, 5, and 7. Okay, hit stat again. Go over to calc, down to number 4. All right, so you get 2 and 1. So y equals 2x plus 1. Okay, so that's not bad. We're going to go to our y equals and type it in. 2x plus 1. Okay, second graph. All right, I don't want to be at 1,000. I want to start back at 0. So second table set, 0. Okay, now look, it's saying y equals 13. So this one's different. This one's different than the other problems we were doing. This one's y equals 13. So here's the y column, and you want y to be 13. So you go down, y is 13 when x is 6. X equals 6. So that's your answer to that one. Hey, number 6. This chart shows the cost of a movie theater ticket at a Midtown theater from 1960 to 1980. Using a linear model, what year would the price be? Approximately $3.50. So I go to stat, put them in. All right, I'm going to let you put them in stat and get your y equals, and then I'll help you after that. All right, if you're not done putting them in, pause the video. All right, so your y equals 0.087x minus 169.7. If you did not get that, pause the video and go back and double check your numbers. Make sure you entered them in correctly. So now I'm going to go to the y equals, and I'm going to type in 0.087x minus 169.7. All right, I'll go to second table. Need to see what the question's asking. Saying, using a linear model, what year would the price be approximately $3.50? So $3.50 is a cost. Is that in the X row or the Y row? Well, that's Y. So we want Y to be $3.50. If you look, it starts in 1960. So let's tell the calculator, let's go to second window, and let's start in 1960. Okay, good. Those numbers look a lot better. And we're looking for $3.50 in the Y column. So up and down. So $3.50. So that happens in 1991. 1991 is your answer. Right? Number 7, the table shows the average attendance at a football team's games in different years, assuming a linear trend. And what year was the team's attendance first predicted to be greater than 20,000? So put these in stat. All right, 7, 6, 5, 0. All right, stat, count. Okay, so I need to write this down. Y equals 863.25 x minus 1718628. All right, where do I always have to put my y equals equation? In the y equals, good. 863.25x. Pause the video if I'm going too fast. Okay, and second table. Okay, look, those numbers don't make sense. Let's look and see. It starts in 2000, so we're going to go to second window and start it in 2000. All right, the question says, when will the team's attendance be 20,000? All right, attendance is a Y value. So 20,000 is a Y. So we're looking in the Y column for 20,000. And so you look in your Y, 20,000. That first happens in 2015. So that's D. Number 8, the table shows the number of hours spent studying and the exam grade earned. Using a linear model, approximately how many hours would a student study to earn a 97? Okay, you put it in stat yourself. Okay, if you're not done yet, hit pause, but I'm getting y equals 8.2x plus 68.7. All right, so I'm going to put that in my y equals. And go to second table. All right, so let's see what it's saying. Using a linear model, approximately how many hours will a student study to earn a 97? All right, well, 97 is an exam grade. So we're looking for that in the y. And a good place to start would be 0. That would be a good place to start for this one. So second window, tell it to start at 0. And we want to make a 97. All right, so they're going to make a 97 between 3 and 4. So they'll make a 97. So what answer choice is between 3 and 4? Good, B, 3.5. Number 9, the table below shows the number of hours Tammy worked during 5 days and the amount of tips she earned. What is the difference between the observed value at 7 and the predicted value at x equals 7? Okay, you put them in stat. Okay, so this one you're going to have to round. So you get y equals 15.591. The 0 rounds up because there's a 9 next to it. X minus, pay attention to that negative, 31.864. The 3 rounds up. Okay, so I'm going to put this in my y equals 15.591 x minus 31.864. Okay, this is the last type of question we're learning today. It says, what is the difference? What does that mean? Subtract. Good. So I know I'm going to have to subtract. Between the observed value at x equals 7 and the predicted value at x equals 7. Okay, so this y equals is our function rule. All right, so this is our function rule. Sorry for my sloppy handwriting. Okay, so we got our function rule. Then we're going to do the observed value. So we got to find two different things here. So we're going to do the observed value. Observe means to see. What do you see up here in the problem at x equals 7? Well, here's x, and there's 7. What does Tammy earn when she works 7 hours? She earns $90. So that is the observed value. Please write that down. So observed is 90. All right, now we need to get the predicted. Well, the predicted comes from the calculator. So we've got this typed in our y equals. We've already done that. We're going to go to second graph like we always do. And we're going to go to x equals 7. So go down to x equals 7. And the calculator predicts she'll make 77.273. 77.273. All right, well, the last thing you have to do is the difference. You have to subtract the observed and the predicted. So your answer is going to be 90. So to go to the main screen, you hit second quit. It's going to be 90 minus 77.273. So the answer is 12.727. That's the answer. Okay, so you got a couple steps. You are capable of doing that. Number 10, the table below shows the charge for different numbers of shirts from an online website. The company charges a cost per shirt and a setup fee per order. What is the difference between the observed and predicted total cost of earning 150 shirts, of ordering 150 shirts? Okay, you put it in stat, you do that part yourself. Okay, if you're not done, hit pause. Okay, the y equals I got is negative 0.108x plus 365.1. All right, you're going to go to your y equals in the calculator. And you want to type that in, negative 0.108x plus 365.1. Go to second graph. Okay, so it's asking for 150 shirts. He wants to know the difference, so that means to subtract, between the observed and the predicted cost of ordering 150 shirts. So this is my function rule. Next, I'm going to talk about the observed. Observed is what you see. What do you see in the table for 150 shirts? Well, it's going to be 354. 354. Now, to get the predicted, you have to use the calculator. Okay, so we already typed it in. And so I'm going to do the shortcut, second window, go to 150. And the calculator predicts for 150, 348.9. All right, the last thing I have to do is subtract because it said difference. So 354 minus 348.9. When you type that in the calculator, you get 5.1. So that is your answer, 5.1. All right, number 11. For her birthday, Aisha received a gift card to the mall. Her gift card balance at the end of each hour of shopping is shown in the table. What is the difference in the observed and predicted value for 4 hours? All right, put them in stat, guys. Almost done. All right, if you're not done, pause this. All right, the y equals that I got to go 3 decimal places, negative 17.893x plus 103.299. You had to round up on that one. All right, so that's the function rule. All right, it's asking for the difference. That means to subtract between the observed and the predicted for 4 hours. Well, if you look, hours is your x, so you want x to be 4. So the observed is what you see. Well, what do you see at 4 hours? She has $35.45 left on her gift card at 4 hours. Now, for the predicted, because it says the difference between the observed and the predicted. For the predicted, you have to use the calculator. So I need to type this in, my y equals negative 17.893 x plus 103.299. Okay, so I want 4 hours. So I'm going to have to go to my second window. A good place to start would be 0. Because if you look up here. And for 4, she'll have, the calculator predicts she'll have 31.727. 31.727. All right, the last thing you have to do is subtract because it asks for the difference. So the answer is going to be 35.45 minus 31.727, and you get 3.723 when you subtract them. All right, last one, number 12. The table below shows the number of residents in a neighborhood who received new water meters over several weeks. What is the difference in the observed and predicted value for 2 weeks? All right, so the first thing I want to get is the function. So I put it in stat. All right, pause it if you need to. Get y equals 22.7x minus 3.8. All right, let's do the observed next. So the observed is what you see. So for 2 weeks, you see that there's going to be 29. So the observed is 29. All right, the predicted, we have to use the calculator. So you type it in your y equals 22.7 x minus 3.8. and we want to know for 2 weeks. For 2 weeks, the calculator predicts 41.6. Last thing you have to do says difference, so you're going to have to subtract these. So 29 minus 41.6. You could put a negative or a positive, but you get 12.6 as your answer once you subtract them. Okay, so just to recap, the first problems gave you what x equaled. So when you went and looked, you had the x. So you were looking in this column for x equals 4, and you had to get the y value. Then some of the problems gave you the y value, and you had to find what the x would be. So you have to pay attention to what number they give you. Is it an x or is it a y? Here it was a y. The last problem said for the difference between the observed and the predicted. So you had to find what the observed was and the predicted and subtract them. All right. Make sure you use your notes when you are doing your worksheet.